The subject of my talk is Earendil, which is a band-resistant decentralized network. So before I talk about the tech, I'll give a very brief intro of myself. I am the founder of Gef, which is a trust minimizing censorship circumvention tool / VPN. I'm also the founder of Mel, which is a newer project I'm working on, which is to build a root of trust minimal blockchain to secure off-chain post-web protocols with light clients, which is, I think, the killer use case for L1 blockchains, but is currently very hard to do with current blockchains. And so my background is really mostly in privacy tool research and kind of like old cypherpunk technology, who I only recently in the last few years entered the Web3 and crypto world. And that kind of goes into what I mean by band resistance, which is that I've noticed that when people say the word censorship resistance, they mean totally different things in the privacy tool community and in the Web3 community. In the privacy tool community, when you say censorship resistant, you mean ban resistance, which means that you can't ban the protocol off the internet, even if you're the ISP, if you're a nation state. This is what the sense you use when you talk about stuff like Tor pluggable transports, like steganography, plausible deniability of web traffic. But when in crypto / Web3, most people mean what I call filter resistance, which is that the protocol itself doesn't discriminate against particular users or use cases. So, we say that Monero is more censorship resistant than Bitcoin because nodes on Bitcoin could theoretically censor people's transactions, but not on Monero. And here we really talk about Slavic encryption, zero knowledge, et cetera, rather than steganography and plausible deniability. And I think this causes a bunch of confusion because these two concepts are completely orthogonal, but people confuse them all the time. I've seen people, including, for example, my own users in Gef, say that, oh, ITP is hard to block because it's a peer-to-peer VPN, and that somehow makes it hard to block. It's not at all. It's just as easy to block. You also see people in the security community think, okay, the crypto people talk about censorship resistance, and that's clearly just a scam because you can just block all Monero traffic with any deep packet inspection equipment. And I think that that's a huge problem because we actually want both. We want band resistance, filter resistant, decentralized networks. But the problem is that that's actually really, really hard combining these two properties because on one hand, decentralization and encryption basically solves filter resistance. If nobody can censor your transactions centrally, and nobody can even see what you're doing on the network, then obviously you can't discriminate against different use cases. However, our best band resistance technologies now require trust and centralization. So for example, with Tor, the way they try to solve this is with something called bridge distribution, where you have a central authority that has the list of all the nodes, and it carefully gives different users of the network different sets of nodes to connect into the Tor network over some secret set channel. And the idea is that that way no one person can discover all the nodes on the network and ban them all. And we also rely on technologies such as collateral freedom, such as relying on too big to block Web2 platforms like GitHub that we also assume are on our side that wouldn't collude with the bad guys trying to censor us. For example, we might distribute the software over GitHub. We might give people this initial bootstrapping information over GitHub and just trust that on one hand, let's say China is not going to block GitHub. On the other hand, GitHub is not going to block us. So this is very much not in alignment with all this post-web decentralization stuff we want to build. So Earendil is my attempt at building a protocol within the Mel project that is band resistant, filter resistant, but also fully decentralized. And the idea here is that not only when you use Earendil to communicate, it's like an end-to-end communication network, you can't be censored on the network. You also can't be censored by your ISP, and your ISP shouldn't be able to know that you're using this protocol. And ideally, I want this to work even if the whole world is basically China's internet under severe monitoring and censorship. So how do we actually decentralize band resistance? Is it even possible? I mean, our current systems all use centralized trusted parties. So the answer is, if we talk about invite-only networks, when you have to be invited by someone in the network to join, the answer is somewhat obviously yes. Because there is one kind of network that's obviously decentralized and band resistant, and that is a friend-to-friend gossip network. And what that means is that you have a bunch of nodes in a network. Every user is connected with a few friends with secure obfuscated protocols. What that means is that unless you're one of the friends, you don't know that they're talking. We actually have the technology to do this, mostly from the Tor community and similar projects. I wouldn't go into the technical details of this too much, but this is definitely possible, to have a protocol where two people talk, nobody else knows they're talking, unless they're one of the two people. And users also only know their friends, and they never learn anything about the rest of the network. So users join by being invited by a friend, but they only ever talk to their friends, and they broadcast networks by gossiping to their friends, and they don't know who else is in the network. So you have something like, and in such a system, basically, everything is band resistance because, first of all, the sensor can't find out who's using the network by just looking at packets. That's because of this obfuscation protocol. And also, the bad guy can't find out who's in the network by trying to enumerate the nodes, by asking around, are you a node? Because every person only talks to their immediate neighbors, they don't talk to strangers. So a censor actually has to be invited by every single person they want to censor. And that doesn't really scale for mass censorship at all. Now, the problem is that what we have here is merely a broadcast gossip network. And that's kind of useless for most protocols. I think probably the only thing you can build on this is a blockchain, which is pretty useful, but it's not the whole internet. We need to add some kind of routing to this system, and where I can send a message to a particular node somewhere else on the network without broadcasting it to everyone else. And that's actually really hard without ruining band resistance, because most of the times when you have a peer-to-peer routing system, if you actually read how it works by everyone sharing data about where nodes are, reshaping the shape of the network, like in a DHT, to enable faster routing. And that doesn't work because it means a bad guy can come in and exploit all those rules to discover the entire network topology, discover everyone's IP addresses, add them into a blacklist, and ban the whole network. So my first try for routing is small world routing. So that's a technology that was invented by, I think, the Freenet project. And the idea there is that even if you don't know anything about the network, you can kind of send packets roughly in the right direction with some heuristics, and hopefully they eventually get there. Unfortunately, that turned out to be very unreliable unless your network topology is of a particular shape. It works relatively well for Freenet because it's a publishing system, and as long as data eventually propagates, it's fine. It doesn't work for a real-time, low-latency communication system. So instead, Earendil's solution is that we can gossip the adjacency graph. We can have everybody know which node is next to which node, and nothing else. We know that which node is next to which node, but we don't know the IP addresses. We don't know the obfuscation protocols used for anyone except our immediate friends. So you can imagine I'm a node in a graph of nodes. I know the shape of the graph, but I only know how the links to my immediate neighbors work. I know that there are links elsewhere. I have no idea how they end up communicating. So now I can then search through this graph to find a route to my destination and use onion routing, similar to projects like NIM or Tor, where I pick a path, I encrypt a packet so that with a header that tells it to go to that path, and I send it off into the network. So the really cool thing is that if I only gossip this graph, I don't break band resistance. I know the shape of the network. I don't know enough to block it. So the final problem is, how do we actually pay users to run infrastructure here? Because a big problem with projects like Tor is that everyone wants to use it, nobody wants to contribute to it. And this is especially problematic here because people actually have to put in a lot of effort to join. They have to, try to advertise their node to friends and things like that. And the usual solution to this in the crypto space is let's invent some complex tokenomics with reward scheme or proofs and things like that. It turns out we don't need that at all. We just need to pay per packet. Every time I send a packet to my friend, I pay them. More precisely, like the protocol records that I owe them a certain amount of money based on a mutually agreed gas price. And then I can settle this later on with whatever payment method we both agree on. And so it's completely decentralized. There is no incentive mechanism that's centralized, but this really does work. And Earendil also comes with a built-in debt settlement protocol, which is based on an anonymous payment channel network built on the Mel blockchain. And the communication for that payment is also overlaid back onto Earendil. So Earendil is used for payments and also needs payments. And it also has this other payment method, which is a fallback payment method where you waste a bunch of money, waste a bunch of computation in order to settle a small monetary debt. And that's used for bootstrapping because you have to talk to your friend to pay them, but you can't pay them, you can't talk to them without paying them. So you have to have a way of paying them without actually paying them. So ultimately what this ends up implying is that Earendil is not just a data transfer protocol, but it also is an integrated money transfer protocol that's off-chain and anonymous and private. And we can use this both for communication and financial transactions. So how would you use and contribute to Earendil? So unfortunately, Earendil right now is not useful. It's not ready to use. I'm still not completely done with the design of it. For example, one really interesting feature I think that is important is to not only have onion routing, but also mixing and delays so that timing and like an attacker observing you using the network can't guess at what you're doing with it. And that requires some more thought on how to design that. The code itself, the core transport is about half done. The payment stuff is about 0% done, mostly because we actually have to build this payment channel infrastructure first, but we will be releasing kind of an alpha non-incentivized version and testing that before we have incentives done. So what can we use Earendil for once it's done? Well, it will actually be a very foundational protocol in the Mel ecosystem. The Mel's whole idea is that we shouldn't build the post-web on-chain. We should build it off-chain, but have certain important parts on-chain, which requires light clients that let us talk from off-chain to on-chain without actually trusting gateways. And this is going to be a foundational protocol in that whole model that enables use cases that are huge. Anything that needs ban resistance when you're building a protocol where you actually don't want people to know that you're using this protocol because the ISP could block it or the person using it could get into trouble, then you should consider using Earendil as your underlying network transport. And another use case in the pipeline is something I briefly touched on previously, which is Geth. So Geth is a trust minimizing VPN project I run that currently has about 400K users. And Geth currently is very centralized. It's trust minimizing because people authenticate with a blind signature scheme, but that doesn't fully fix all the problems. Eventually, I want Geth to merely be a front end to the decentralized Earendil network with some proxy nodes at the end to help them relay traffic onto the internet. And this will onboard a bunch of users into Earendil, and probably an ecosystem would form just catering to this user base, running relay nodes and charging fees. And if you want to contribute to the Earendil project, I do want Earendil to be a wider community project rather than just an official Mel project because, well, Mel is supposed to really focus on the blockchain, and this is a much wider use case that's backed by Mel. And if you're interested in things like protocol obfuscation, mixed nets, payment channels, or anything related to decentralization or ban resistance, we would love for you guys to give any feedback and maybe even some pull requests. And we'd also love any feedback on what would you want to build on Earendil, because I do think that a ban-resistant, privacy-protecting transport layer enables a lot of apps that we haven't seen yet in this space. So yeah, and thank you all guys for listening to my talk. These are some links to the website, to the GitHub, also the section of the Mel Discord that is on Earendil. I would really love to connect with you guys further and maybe like just chat more about what we're building. So yeah, thank you everyone.